video will show you how to perform a linear regression using R. Unlike a correlation analysis, where you are looking at the relationship between two variables, a regression allows you to understand and then predict how one variable affects the other. In our case, you can see in this plot, we want to find out how the length of gestation affects the baby's birth weight, and then plot this model line in red, which essentially predicts the birth weight from the gestation period. So here we are using the birth weight dataset, and to load our file into R, we first have to download a package. This is because we're going to be using a function to import our dataset that is not in the base R functionality. The package we are using is called Haven, and we need to use this package because our dataset is in a SAV file, a format used by SPSS that base R does not recognize easily. So, to install the Haven package, we type install.packages and then in brackets and quotation marks, Haven. This will install the package forever, so once you've installed it, you won't need to do it every time you've used it. So I'm not actually going to run this line of code as I already have the Haven package installed. What you will need to do every time you want to use the package, however, is to load it from the R library. So to do this, we type library and then in brackets Haven. So to load the package, I'm just going to run this line of code, and now it is loaded into my R environment. Okay, so now we have loaded and installed our package. We need to set our working directory to tell R where to find the SAV file on our computer. So to do this, we type set wd working directory, and then we type the working directory in quotation marks and brackets. So I'm just going to run this line of code. So this has set my working directory. Alternatively, you can go to session, set working directory, and then choose directory, and then you just click the folder where your file is kept. Next, we need to import our file into R. To do this, we'll use the read SAV function from the Haven package that we've just installed, and we will type read_SAV and then the title of your file in brackets and quotation marks, and we're going to assign this dataset to an R object called myData. So if I just run this line here, so now you can see that the dataset is imported into R and is stored in this object called myData. So if I just click on this R object here, it will open a new window where we can look at our dataset. So we have 42 individuals and lots of variables. However, we're interested in the gestation age at birth and the birth weight. So to calculate a linear model of these two variables, as I've previously done here, we need to type lm open brackets and then our outcome variable, which is the y variable, so birth weight, a tilde sign, and then the predictor variable, which is gestation, our x value. And then we need to tell R where to find these two variables, and so then we type data equals myData, which is our data set. And then we're going to assign the results of this linear model to an R object called res. And I should just say that you should make sure that these variables are typed exactly as they are in the data set here, otherwise R won't be able to recognize them. So if I just run this line of code, so here we have the results of our linear model up in our R environment in the object called res. So now we need to summarize our results. So we type summary and then in brackets res. So if I just run this line, and here are our results. So let's have a look at this output. So first of all, R tells us the formula that we've just inputted. And next we have the residuals, which are essentially the difference between the actual observed response and the response values that the model predicted. So the residuals are essentially the distances of each point from the model line. Next, we have the coefficients of the model, and we're interested in the intercept and the slope, which are these two rows here. The intercept is essentially the point where the function crosses the y-axis when x is 0. However, in our case, x can never equal 0, as it's impossible to have a gestation period of nothing. So in our case, the intercept is not valuable. The slope, however, is more meaningful, as it tells us for every increase of 1 in gestation, birth weight increases by 0.35530. So this essentially also determines the angle of our model line. We can look at the standard error of this value, which is low at 0.05, which means that we'd likely get a similar result if we ran the model again and again. We can also look at the t-statistic, which we want to be as far away from 0 as possible, as this would suggest we can reject the null hypothesis that there is no relationship between gestation and birth weight. Then lastly, we can look at the p-value, which is what we want to be below the standard threshold of 0.05, which we can see that our result is from these significance codes. So this means that the relationship between birth weight and gestation period is statistically significant. Then we can look at the residual standard error, which is a measure of the quality of the linear regression fit. Now we go on to the multiple R-squared and adjusted R-squared. The R-squared statistic provides a measure of how well the model is fitting the actual data in terms of the proportion of variance. It always lies between 0 and 1, so a number near 0 represents a regression that does not explain the variance in the response variable very well, and a number closer to 1 does explain the observed variance in the response variable. So here we have a multiple R-squared of 0.4988, so we can say that 49.88% of the variance in birth weight can be explained by the gestation length. If we have multiple variables, say for example in a multiple regression, the R-squared value will always increase as more variables are included in the model. So therefore, we always tend to use the adjusted R-squared, as it adjusts for the number of variables considered. Finally, we can look at the f-statistic, which is a good indicator of whether there's a relationship between our predictor and the response variables. The further the f-statistic is from 1, the better it is. And finally, we have the p-value, which is, in this case, statistically significant. So we can conclude that the gestation length has a significant effect on the baby's birth weight. So there is a quick summary of how to perform a linear regression model in R using RStudio.